All right, so here we are with the 3-5 notes, day 2. We did some part of it the other day where we talked about curve fitting and we talked about correlation coefficients and things like that. So this is your day 2 notes where we ended the other day by graphing each of the coordinates that we were given. It was about a basketball game and the number of minutes played and then the number of points that had been scored. And we talked about how it has a positive relationship due to what we talked about with correlation, because it's going up. The data kind of trends this way up from left to right. And then it also is actually pretty solid because it's kind of following that line. There's a few points that are a little bit of an outlier, but we will get to that here in a minute. So right now what we're going to do is get out a graphing calculator, and again that's why it's on my screen here, because we're going to go to intermediate algebra, the overview, and we're going to access the calculator. Remember that the directions say to press start, and then click the calculator image. So start and little calculator up here brings us to our newly set calculator. So what we're going to do here is we are going to find this line of best fit. So there is this line that, as I drew earlier, kind of goes through the data. Most of the time, there will be an equal number of data points above the line as below. That's usually what happens. Some of them may be on the line. It just depends. And this is my estimation of the line. We'll see what it actually is in a minute. But the idea is that basically we take the measure of the distance between every single point and this assumed line, and we try to find the lowest average that would be the distance between them. So there is a way to do this by hand, but we will not be learning it because no thank you, okay? Instead, we will have our calculator kind of find those averages for us. So in order to do that, what we need to do is make sure that our diagnostic is on your calculator. So this is where we would kind of type what, because I'm on a computer, what we would want to identify here. So, all right. So in order to turn your diagnostic on, the fastest way to do that is actually to go to your catalog, which is down here. So we're going to press second and then the 0 button, which is going to be for the catalog. All right, once we're in that catalog, so here's second and 0, we're going to scroll down to diagnostic on. So scrolling, and here's our diagnostic on. And it is a program, and so you do actually need to make it happen by entering. So we're going to scroll down to diagnostic on. And then after that, diagnostic, it's not going to be a good word. And then you're going to press enter and then actually enter again. So here we are, diagnostic on, pressing enter. So it's bringing it to the home screen. And then we actually want it to run. So it's going to say done at the end. So we're going to change that. All right, so that's kind of the first thing that you're going to need. And the reason that we have to turn our diagnostic on is because otherwise we will not be able to find the coefficient that tells us how close this line fits to the data. So we need this for our data exploration. So then we need to input the data into the table. So in order to input the data into the table, we're going to end up going to stat, because we're talking about statistics here, about how statistically likely the next in the next set of minutes you'd have a score. So we're going to press our stat. Button, and then from the stat button, we're actually going to number 1, which will be edit, and we'll press enter. And from there, you're going to put your list 1, we'll go over that in a second, as your X values. And then we're going to do list 2 as your Y values. All right, so going to stat, that's this button here. Notice we have the number 1 here, which says edit. We'll press enter to get there, and now we have all of these columns. So we're actually going to input the data that we have from our table here. I'll move that over so I can see it into these tables. So I'm going to put in 28 for the first one. So these are all my X values. 35, you can actually type it with your with your keyboard if you would like. Not all of the operations work well on your keyboard, so it is best to actually press the buttons for most operations. And of course I messed one up, so I need to write 15 there. Always double check that you put in the data correctly, because sometimes it doesn't work so well. 23, 19. All right, and then I'm going to go to list 2, which is my Y values. Oops, apparently I can't type that fast. 2, 12. So we're inputting all of the data so that the calculator can actually figure out what the line of best fit is. All right, so those are all our values. And so now we're going to go back to the home screen and get our line of best fit. Gotta help someone with a remote control here. All right, there you go, hon. Okay. So in order to do that, we're going to go back to the home screen, which is second quit or second mode there. So I'll type that in here. All right. It's kind of the second thing we're doing. So go to the home by pressing second quit. And then we are going to actually take the data itself and get a linear regression. So we need to go to the stat button again, and then I can't remember the exact values. Let's see. We're going to scroll over to calc. So over to calc. Once we're over in calc, we're going to go down to lin reg, ax plus b. So and that is apparently number 4. All right, 4. There. All right. Then once we do that, you get to press a bunch of enters. In fact, 3 times to kind of get through all this stuff. So let's see. We're pressing enter, and it's saying, "Hey, can you have list 1 as X?" Sure. So we press enter. Then we pressed, is our Y list 2? Yes, it is. And then we have no frequency list, and now we're going down to the word calculate so that we can press enter. I think I pressed it 5 times or something like that. All right, let's move this over. All right, and so now what you get is actually your equation for your line of best fit. So notice it's giving it to you as y equals ax plus b. And then they're telling you a is this and b is this. So I'm going to be fancy because I have a computer and take a picture of that. Also going to put this here because that's actually how to find it. And then we're going to put our little picture over here so that we can write down what we got. So for your line of best fit equation, we're going to use this exact equation, y equals ax plus b, but of course, instead of a, we're going to fit in that very long decimal equation. So let's see here. So instead of an a value, I'm going to put 0.7746. You do want to use in the middle of a problem up to at least 4 decimal places, so 0.7746. And then instead of a b, we're going to put, minus 5.8004 for rounding appropriately. So that is our equation that we will then put in these x values in order to graph it over here. So fastest way to put in those x values is to have your calculator do it for you. You can, of course, just plug in a 0 right here and realize that it's going to be negative 5.8004 because this will cancel. But it is fun to kind of try it this different way here. So what's going to happen is in the y equals, I'm going to type in the equation of 0.7746, put an x next to it, minus 5.8004. And again, this is just an extra technique. And then I'm going to go to second table. And now I can scroll through any amount of x's that I want in order to get the equation or the coordinate point that goes with it. So just a little trick of the trade there. So that means that for my first value of 0, I'm going to have negative 5.8, which we kind of already talked about. Oops. And so that's going to be right here. I don't really have that on my screen, so I won't be plotting that one necessarily, but I will try to get to the rest of them. So the next coordinate point that we have is if we plug in a 10. So if we plug in a 10 over here, all right, a 10 is going to get us 1.9456. All right, and again, that means that at 10 minutes of play, there's usually around 2 points scored. Interesting. Okay. Moving on, number 20. So after 20 minutes of play, we're hoping that 9.6916 points have been scored. All right, and then we can do 30 and 40 as well. Oops, went a little past, and now one more tick. All right. So 30 is going to be an assumption of 17.438 points scored. And then the last one is going to be around 25.18. Seems to be a very low scoring basketball game. Moving on. All right. So we are going to plot each of those points. And of course, it turns out you can't actually plot this first one because it's down here and we don't have necessarily a spot for that one. So instead we'll go over 10 and up about 2. So it doesn't have to be exact necessarily. We're just trying to get a visual representation. So I cannot officially graph 1.94 on this because I can't be that exact. So 2. Then we have 20 and about 10. So 20 and almost to 10. The next one is 30 and about 17. That is right there. And then the last one is 40 and about 25. Just seeing if I can actually, yeah, there we go. All right. So in order to figure out what's happening here, if we had graphed every single point on this line of best fit, we would be getting something that looks like that. So all I'm doing is connecting each of those points together, those yellow points. There we go. All right, and so as you can see, there happens to be, let's see, 1, 2, 3, 4, 5 dots on top, and then 1, 2, 3 on the bottom, and then there's 2 here in the middle. And so it does try to fit as much of that set of data in the middle, but of course this outlier kind of drags it up. So that is our line of best fit. So now what we could do is use it to estimate something. So for instance, let's say that the next question, which would happen on your assignment, is, so how many points would you expect to be scored if there were 35 minutes played? Well, you'd go over to 35 minutes, and you'd go up, and you're not going to go to the point that we have, but you're going to go to the line because this is the estimation. From that line, you go over to see how many points you would think would be scored, and so you'd say about 21. So our prediction is that at 35 minutes of play, there will have been 21 points scored. All right, and so that's what you are asked to do. And in your assignment, you're going to be doing a few of those. So you are going to have to go through this process here, turn your diagnostic on, make sure the program has been run, so it says done. Then put in your data into list 1 and list 2, L1 and L2, and then actually calculate this line of best fit. Once you calculate that line of best fit, they will want you to actually find something. So another way other than a graph is to actually plug it in. So let's say that we were trying to find, after 35 minutes of play, how many points are scored. Without a graph, you would take the equation that we had before, and instead of this x, you would put in 35, because x is 35. Then algebraically, you would go ahead and solve, and so we know that 0.074746, 0.7 times 35 is actually 27.111. And then from that, we're going to subtract 5.8004. And so we'd be able to say that we're going to have about 21.3106 points after 35 minutes. So, of course, the visual is going to be a lot easier to kind of interpret, right? Okay, but algebraically, you can, in fact, instead of going over to 35, you can just plug in a 35 and see what happens. All right, sounds good. I think that's about all we need for that one. So again, you're going to have your calculator from that link, and then you are going to be able to do some curve fitting and predict.